everyone. My name is Anthony Favier. I'm a third-year PhD student supervised by Rashid Alami. And today I will shortly speak about my PhD work, which is about task planning for a collaborative robot. So we are in the context of the joint action that Rashid introduced earlier. It is about two agents interacting to make a change in the environment, so usually to fulfill a task. And for a good collaboration with a human, we believe that the robot should behave in an acceptable, legible, efficient, and compliant way. And it also comes with a set of assumptions, such as humans and robots are not equal. Humans are naturally uncontrollable agents. They are also cooperative, rational, and congruent. And they use social signals to share their decisions and intents. And so, with all that in mind, I will start by briefly presenting an overview of the HTTP-ADA framework, which is a robot task planner able to, anticipating human decisions. So it uses two distinct agent models, where we have a human model that is used to estimate the possible actions that the human is likely to perform. And based on those, we plan the robot actions and then produce the conditional plan you see on the right. So in a turn-taking manner, it produces implicitly coordinated plans, so there's no need of prior negotiation. And one of the main strengths of this scheme is that it models distinct human goals and also distinct human beliefs. And so this offers a lot of liberty and expressiveness in the problems we tackle. So I would say my main first contribution is to a first extension to this scheme with some concepts of theory of mind. And with that, we allow the robot to more accurately estimate the human's beliefs and to solve false belief tasks, such as the Sally and Anne example. And so to do that, we enriched the problem description with symbolic locations and specifying if facts are observable or not with observability types. And based on this, we designed two theory of mind processes that makes the agent able to learn from observing an action execution or observing directly the state. And thanks to that, we can maintain the human beliefs and then detect if a human false belief is relevant and if it has to be tackled. And when it is the case, we do so by with minimal verbal communication or delaying a non-observed robot action. Then another contribution is to, so another extension of HTTP-ADA, but this time grasping some subtleties of concurrent joint action execution. And here we are still we still have steps, but now the agents are able to act in parallel. And at every step, the human is able to decide either to start acting and the robot will comply in parallel, or the human can decide to be passive and let the robot act alone, or the human can also decide to let the robot start and be compliant with it. So somehow the human can decide to let the robot decide. So this time to do this, we designed a model of execution in a form of an automaton that we can see on the top right. And it is basically based on non-verbal signals exchanged between the agents and explicit perception phases used to synchronize the agents. And so this automaton is used to explore additional relevant courses of actions for the robot. And then, with an estimation of the human's preferences, we're able to generate an optimal robot policy satisfying those preferences, and then execute this policy that is, in the end, compliant to both online human decisions and preferences. And basically, that's the end. Thank you for your attention.
Thank you, Anthony. Questions on planning? So do you have already implemented those strategies in the real case for real robots? Pardon.
Not yet on the real robot, but for many technical reasons. But we designed this interactive simulator where the robot is running the policy we generate, and here a real human with the mouse can click on real time on the different blocks to perform actions. And so it can always decide to act or not, to delay, to act after. And so with that, we are already performing some sort of user study to validate the approach.
Thank you very much. Thank you, Anthony.